This video is part of a series demonstrating the integration of motion control into TIA Portal, as well as the new Synamics V90 drive. In this video, we will be looking at the hardware configuration of the V90 drive. We begin by selecting our controller. In this case, we're using a Simatic S7-1500. We're going to select the unspecified CPU option and allow the software to detect the hardware automatically. Once we find the controller on the network, we simply click Detect to import the hardware configuration. We can now import the V90 to our hardware configuration. If we go to Devices and Networks and across to the hardware tree, Drives and Starters, Synamics Drives, Synamics V90 Profinet, and select our power rating, we can drop it into the project. We start in the network view by assigning the drive to the PLC's Profinet network. The next step is to configure topology. Topology tells the system exactly how everything is wired port by port, in order to provide advanced diagnostics and alarms in the event of communication errors. It also allows us to have very high speed, deterministic, motion communication, and a high dynamic performance as a result when combined with isochronous mode. Isochronous mode is a function available in the S7-1500 which can be used to ensure the motion control program and communications run at specific time intervals. Topology is required if isochronous mode is enabled because the controller needs to know exactly what path it is sending its messages to in order to calculate the time delays and compensate for them. V90 drives, like the one in this project, have isochronous mode enabled by default for optimum servo performance. When the V90 is imported to the project, isochronous mode automatically sets the drive data acquisition and motion OBs to run at exact 2 millisecond intervals by default. The FAQ pictured on screen explains this in greater detail. The motion control interrupt can cause the PLC's cycle time to become very long, especially when the PLC is being pushed to the limit of its motion capabilities. By changing the send clock of the sync domain, or the MC servo cycle time factor, we can reduce the impact of the MC cycle on the CPU. However, this will sacrifice some dynamic performance of the drives. Another method of reducing the CPU cycle time is to reduce the communications load. The default 50% is higher than most applications require, and reducing it can massively improve performance, but network communications may be impacted if care is not taken. We can see from the diagrams on screen how different CPUs respond to different number of axes. A larger CPU can more easily accommodate a larger number of axes. This is all defined by motion control resources. Larger CPUs have many more resources than smaller CPUs, and each different type of axis requires a different number of motion resources. The motion control resource limits for a CPU are intended as a theoretical maximum. The closer to the limit you are, the less dynamic performance you will be able to achieve from the drives. If in doubt when specifying a CPU, please contact your distributor or a Siemens representative. The next step is to assign the MC servo block to the cyclic data exchange. At the moment, we don't have an MC servo block as it has not been imported to the project. When we import a technology object, it will automatically be added to the program blocks. We can now select the MC servo block from within the drive's cyclic data exchange to link the two together. The only step we have left now is to associate the drive with the technology object. We enter the configuration tree, into the hardware interface, and select the drive from the drop-down menu. We are now ready to download the configuration to the CPU.